Okay, moving on in our notes. This one is show that there's a continuous extension at x equals 2 and find that extension. So what we're going to do here is we're going to factor the bottom out. That factors out to x minus 2 and x plus 2. On the top, I'm going to factor that out. That factors out to x plus 3 and x minus 2. Those cancel, and I'm left with x plus 3 over x plus 2. Now, if I had looked at my original graph, there would have been a blank spot here at x minus 2. So that's what we have our continuous extension for, is for that point. And so what we can do now is, in order to find what that extension is, we plug our limit in. So the limit is x approaches 2. And now I can plug it into this equation, since that's not going to give me a 0 on the denominator anymore. So it would be 2 plus 3 over 2 plus 2. So that's 5 over 4. That's going to be my continuous extension. Now, if I look at this, I still have a x plus 2 in the denominator, which means that at negative 2, it's still going to be discontinuous. Almost said that wrong. So it's still discontinuous at x equals negative 2. So whenever I go to put my extension in now, I can create this piecewise function where it would be our original x squared plus x minus 6 over x squared minus 4. And that would be everywhere except 2 and negative 2. And then I could do 5/4 at x equals 2. So now I remove that discontinuity at x equals 2. That's all that it asked us to do. The reason I can't remove it at negative 2 is because when I look at this, if I trace my line here, we had that hole at 2, but it was just a hole. So that's a removable discontinuity. And here, it's an infinite discontinuity, because we have an asymptote. So I can't remove any discontinuity here. For your homework tonight, I'm going to have you identify some of these discontinuities and see if you can remove any of them. But yeah, you would just write it like this. You could also have just written your answer as the continuous extension to x equals 2 is 5 over 4. You would have to write all of this out instead of doing your piecewise function. I find that even harder than just doing the piecewise function. I mean, I'll accept some abbreviations. Continuous extension to x equals 2 is 5 over 4. That's fine. All right, intermediate value theorem for continuous functions says that a function y equals f of x that is continuous on a closed interval ab takes on every value between f of a and f of b. In other words, if y naught is any value between f of a and f of b, then y naught equals f of c for some c within the interval a to b. That's a lot of words to come back to something fairly simple. What that means is if I have a graph and I have an interval from A to B, okay, and I'll just put numbers in so it's more understandable. So this is 1 and this is 5. So I have this interval from 1 to 5. Then if this is continuous, we're assuming that it is continuous. Then if I plug 1 into my function and get a number, say 3, and I plug 5 into my function, get another number, say 7, then if I pick a number between 3 and 7, say 4, then there has to be some x value that I can plug in between 1 and 5 to give me the number 4. That's all that the intermediate value is saying. There has to be some number in my interval of the x's that I can plug in to give me any number in between 3 and 7. Okay, if I have x squared over x plus 1, can you tell me what kind of discontinuity that would be? So I can't get rid of anything in the top or the bottom because that's x plus 1 down there. So it's going to be discontinuous at x equals negative 1. You can find that out just by setting that equal to 0. Get x equals negative 1. It's going to be discontinuous there. Almost did it again. So it's discontinuous at that point. And then what kind of discontinuity is it? Well, if I had like an x plus 1 up here that I could cross out, that would be a removable discontinuity. In this case, I can't cross anything out, so it's a non-removable discontinuity or an infinite discontinuity. All right, so from your homework now, we had some problems that we went over, or that we haven't gone over yet, talking about or discontinuities and certain continuities. So we had to say whether this was continuous on negative 1 to 3, and if not, where does it fall? Where does it fail to be continuous and why? So this first one would be not continuous or discontinuous, and the reason would be it has a removable discontinuity at x equals 2. This one would be discontinuous as well, and removable discontinuity at x equals 3. This one would be continuous because there's no discontinuities in it. And this one would be discontinuous and non-removable discontinuity at x equals 1. Okay, so that's the first 4. Number 5 through 10, does f of negative 1 exist? I have to figure out where to plug it in, or I can just look at this graph. Yes, it does exist because I have a solid dot at x equals negative 1. Does the limit as x approaches negative 1 from the right exist? Yes, it's going to 0. What about negative 1? Does it equal f of negative 1? Yes, f of negative 1 is 0. Does f of 1 exist? Yes. It's at whatever this point is, 1, 1. Does the limit as x approaches 1 exist? Yes. So it would be at 2. Does the limit as x approaches 1 of f of x equal f of 1? No. because this is at 2 and this is at 1. So is f continuous at 1? No. They have to be the same thing. Number 7, is f defined at x equals 2? No. The reason it's not defined at x equals 2 is because I have a less than and a greater than, but no equal to. Is f continuous at x equals 2? No. There's a hole here with no replacement. At what values of x is f continuous? So f is continuous from -1 to 0, from 0 to 1, and this would be a bracket and then a parenthesis. This one from 0 to 1 is going to be parenthesis and parenthesis. Then it's going to be parenthesis 1, parenthesis 2, and parenthesis 2, parenthesis 3. What value should be assigned to f of 2 to make the extended function continuous at x equals 2? Well, the limit as it approaches from the left goes to 0 and from the right goes to 0. So I would say that it would have to be 0. To what new value should f of 1 be changed to remove the discontinuity? You would change the value of f of 1 to 2, making my limit the same as what the point is. So it would just move this point up to here. All right, guys, that is it for going over the homework and for this section. We only have one more section left in this chapter. I'm going to give you some homework problems on continuity tonight, and then you have one more section left in the chapter. So start preparing yourself for a chapter test on limits. All right, guys, have a good day.